Okay, so we move on to question number 2. This is the circle question.
So the first thing I'm going to do is to put the circle equation into standard form. So that involves completing the square. If we look at the x terms, we've got x squared minus 6x, and completing the square on that gives me x minus 3 all squared. But I have to adjust that because if I multiply out x minus 3 all squared, I get x squared minus 6x plus 9. I want the x squared and the minus 6x here and here, but I don't want the 9. So I subtract 9 from the total. Then taking the y terms, I've got y squared and 10y. Completing the square on that gives me y plus 5 squared, which is y squared plus 10y plus 25. And I don't want the 25, so I need to subtract that. Oops. Minus 25. And my equation, my original equation, was x squared minus 6x plus y squared minus 10y equals 11. So my reformed equation will look like that. Rearranging that to smarten it up a little bit, x minus 3 squared plus y plus 5 squared equals 45. And from that form, that's handy because I can now write down exactly what the center is. What did you get? I make it 3 minus 5. And what was your radius? It's the square root of 45. If you got that, well done. Okay, so I can now just look and see if I've actually answered the question. Find the center and radius. Yes, I've done that. Good. Sketch the circle now. So I've got to sketch the circle. Here's my sketch. And I can write the center there at 3 minus 5. But I can't just draw any circle willy-nilly. I need to decide whether my circle would cut through the origin, or whether it is a bigger circle than and actually incorporate the origin, or whether it's smaller and wouldn't actually reach as far as the origin. So what I need to do is I need to find out the length of that line there. And I can do that with Pythagoras. So that would be the square root of 3 squared plus 5 squared. Root 3 squared plus 5 squared is 34. And root 34 is actually smaller than the radius. The radius is root 45. Now root 45 obviously is bigger, so that means that the circle it looks like something like that. The x-axis is here. So what I need to do is to just make sure that I've answered the question, sketch the circle, giving the coordinates of the points of intersection with the coordinate axes. So we're still not finished yet. We've got to find the points of intersection with the coordinate axes. So on the x-axis then, so what is the value of y on the x-axis? It's y equals 0. So when y equals 0, I'm going to put y equals 0 back into that equation there, and I get x minus 3 squared plus 25 equals 45, which means that x minus 3 squared is 20. X minus 3 is the square root of 20. So that means that x equals plus or minus the square root of 20. And then x equals either 3 plus the root of 20, which is this point here, or 3 minus root 20, which is that point there. So the coordinates are 3 plus root 20, 0, and 3 minus root 20, 0 there. Now on the y-axis, x equals 0. So if I put that into my equation, I get 9 plus y plus 5 squared equals 45. Y plus 5 squared equals 36, which means that y plus 5 is plus or minus the square root of 36 plus or minus 6. So therefore 6 minus 5 is 1, which means the coordinates of that point are 0, 1, and then minus 6 minus 5 means that the coordinates of this point are 0, minus 11. So final look up at the top there, sketch the circle giving the coordinates of the points of intersection with the coordinate axes. Have I answered the question? Finally I have, yes. Now once again I've shown you a picture here of the circle as depicted by GeoGebra. GeoGebra is not the only package which you can use, there are others, but it's the one that I use and I'm familiar with, so that's why I'm using it here today. So there we are, we can see the radius EB and the points of intersection with the coordinate axes. Okay, how did you do with that question? Did you get the same answer as me? Did you use the same method? If you used a different method, then which method do you prefer? I'll leave you to answer those questions.